Welcome to lesson 6 of the lower fifth atomic structure. So what we're going to look at in this lesson is background radiation and two terms, contamination and irradiation. So first things, background radiation, what is it? Well, some atoms are radioactive and they emit nuclear radiation. So everybody's exposed to this nuclear radiation from radioactive materials. And what we saw, for example, last week when we were looking at radioactive sources, is that even when there's no radioactive sources out there, there's still some background radiation. The count rate was still increasing. But what we're going to look at today is what caused it. So here are some examples of what causes it. Firstly, here's you. And we're going to have a look at what goes on. So what we have is every hour, 500,000 cosmic rays pass through you. And cosmic rays are rays from outside of the Earth. So they might be from the sun, might be from a galaxy, and even other galaxies pass through you. But 500,000 pass through you each hour, which is a lot. Our food. So for example, 15 million atoms of potassium-40 decay inside you every hour. So you might actually have heard that bananas are full of potassium, and so bananas are actually radioactive, and if we eat our food, 15 million atoms of this potassium-40 decay inside you each hour. In the air, there are 30,000 radon atoms decay each hour inside of your lungs. So even inside your lungs, there's radioactive decay and radioactive particles. From rocks and building materials, they've got radioactive materials in as well. And 200 million gamma rays, so gamma particles, pass through you each hour, which is a lot. However, having said all these big numbers, most people actually live their lives without being harmed by any of this background radiation. And this is because even though there's lots of it, it's all very weak. And due to the properties we saw last lesson, most of them are gamma rays, and they aren't very ionizing. So here's a pie chart showing the different exposures. So what we can see is most of radioactive exposure comes from radon on the air. The next amount comes from medicals and hospitals and all of their x-rays. Then we've got the rocks and the ground, your food and your drink, your cosmic rays. And notice this, only about 0.3% comes from man-made sources. For example, nuclear weapons, nuclear reactor explosions, for example, from Chernobyl. And then also air travel actually adds to it, about 0.2%. But we can see by far the biggest contribution to background radiation is from the radon gas in the air. So, background radiation is nuclear radiation that's around us all the time. Most of it comes from natural sources, but a very small amount comes from artificial sources caused by human activity. So, what is ionizing radiation? So what we've seen is that radiation can be ionizing, and radioactive materials emit ionizing radiation, and this can damage living cells. So if you remember back to last week, ionizing radiation can remove electrons from the atom, which turns them into positive ions because they've lost their negative charge from the electrons. And this can damage the living cells and the DNA within the cells, and this eventually can lead to cancer. The radiation can damage your DNA, but this damage rarely leads to cancer because DNA can actually damage it yourself. And radiation damaged DNA, for example, in sperm and the ovum, can produce genetic defects. So if your DNA is damaged because of this ionizing radiation, your children can have genetic defects. So, what are some of the hazards? So, radioactive materials in the environment, whether natural or artificial, do expose people to risk. And this happens in two following ways. These are the two key terms. Firstly, the radiation from the materials can damage the cells of a person directly. And this is something called irradiation. So if something irradiates you, it can damage the cells of the person. However, we've got this other term, contamination. And this is when some of the radioactive materials can be swallowed or breathed in. And then whilst inside of a body, the radiation it emits can produce damage. And this is damage by contamination. So notice the difference between irradiation and contamination. Irradiation is radiation from material that damages the cells of the person directly. However, contamination is when you swallow or breathe in the radioactive material, which then damages the body. So, irradiation is when you're exposed to radiation from a radioactive source that's outside of your body, and contamination is when a radioactive source enters your body, or it gets in your skin or your clothes. So, I've spoken a little bit about radon gas at the start, and radon gas is a hazardous gas, and is produced normally in rocks when unstable radium atoms decay into radon atoms. And the hazards due to the radon are different around the country because some rocks emit more radon than others. And notice here, for example, this is where we are. This is a Peak District. There's lots of radon gas in the Peak District, right there. So, radon gas, which is a particular hazard if it builds up in enclosed spaces and breathes in. Because it emits alpha particles, and if you remember, alpha particles are the most ionizing, the most penetrating, they can damage your lung tissues if you breathe it in. Radon isn't an irradiation risk. However, if you become contaminated, aka it gets inside you or on your clothes, the risk could be severe, and you'll be at risk of cancer, could die or be very ill. And the reason it's not an irradiation risk is, remember, alpha particles can be stopped by the skin. The alpha particles won't get inside your body from the outside. They can only damage your insides if it's already inside you. So, how can we protect ourselves from this background radiation? And this is something that radiologists and other people who work with radioactive materials need to think about all the time. The first thing they can do is simply limit the amount of time they're exposed to the radiation and the radioactive materials. Distance, if they hold it out, like if they hold the source away, they're going to create a bigger distance and therefore there'll be less exposure. Or they could stand behind a screen, for example, and use shielding, or even go to a different room, which is going to be both distancing and shielding. Because shielding is used whenever possible to basically put something between you, something lead, something some concrete, anything that can get you away from the radioactive material. And these are ways which you can minimize the risk to radiation. So, here are some examples again. We can wear protective clothing, which prevents irradiation. You can wear masks to prevent breathing in materials. Keep as far away as practically possible by handling with tongs. Keep your exposure time as low as possible. And keep the radioactive sources stored in lead-lined containers when not in use and labelled appropriately with hazard symbols. And finally, monitor exposure using detector badges. Okay, so this is all there is to know about background radiation, contamination, and irradiation.